Okay, I think I'm live right now. Today is going to be an interesting stream. I am streaming on YouTube this time, and this is going to be a computer programming stream. Now, I'm using Streamlabs this time because I have it configured to use YouTube, whereas OBS is using Twitch. I figured why not just use different programs for different things. Let's see here. Does it Oh, let's see. Oh, sign into chat. Let's see. How do I? Oh, okay. Well, I'm not going to do that right now. I'm not going to do that right now. Um, I'm just going to stream this because I'm going to be doing some programming. So I'm recording whatever's on my desktop. So I'm going. This is my GitHub repository that I created for what I call Chase Chess, like Chase Triss was for my Tetris game. This is the source code that I have. Okay, wait, I just realized something. This doesn't actually have all the assets that I need. Okay, so let's see, 2 weeks ago, when was the last? That was January 19th, 2024. So technically, okay, all of the source code is here on the GitHub, but some of the other files required are not here. So for that, I'm going to go to my Patreon account and I'm going to download the zip that I uploaded of the last update. Here's my Patreon, and I'm going to go down until I find. Okay, Chase Chest, January 19th. That was when the source was last updated. So you have to understand, I developed all of this on Linux. I had let's see here. Let me find a place to download this. Okay. I'm going to download this to the temp folder because I built this all on Linux and I've never actually tried to compile and run on Windows before. But theoretically, it should not be too difficult. So now I've downloaded the file, I know where it's at. So I'm going to go to the temp folder. I'm going to delete that Tetris DS video. I don't need that anymore. I'm going to extract the source code for Chase Chess. Okay, so Chase Chess source, and it's in the temp directory right now. But let's see here. What I'm going to do is, and I'm going to, okay, it has everything needed, should be right in here. We're going to delete the executable because that was Linux executable. The Visual Studio Code file is probably not going to apply here because it was made for using Linux. So like, for example, let's take a look at this file. This was the Visual Studio Code file for the directories on Linux. So you can, as you can tell by what it says here. So technically that's not going to apply in this particular case because I'm on Windows. So what we're going to do here is we're going to delete the Visual Studio Code folder there because that's not applicable. So what I'm doing is I'm going to rename this folder. We're just going to call it Chased Chess. Okay, so we'll call it SDL Chased Chess. And that's important because I'm going to put it into the same, I'm just going to copy this into the same directory structure because I have my programming files. And this has all been copied over from Linux. Now, not all of it is as up to date as what is on Linux because Linux is my primary programming OS. But I'm going to try seeing if this builds okay on Windows. and then transfer back any changes I make to my Linux computer. I just happen to be on the Windows computer right now. So here's what I'm going to do. I have a development environment already set up, but let's try something. See, I'm going to go to terminal and type make because I have Scoop installed, I have GCC, I have SDL, I have everything installed. So now what you see here is you see that there is a chessboard with two different shades of gray. And notice how when I click on the squares, they change color. But then it also shows where pieces would theoretically move to. However, there are some things that are not entirely right with it, some things I want to fix. So for example, the bishop, see, it shows with the red that it can't move onto the pawn because that's the same color. White can't capture its own pieces. And then it does green for the empty spaces that it can move onto, but a bishop can't actually jump over a pawn and move on to those spaces. So it has some errors. But this program is already not behaving the same way it does on Linux. So let me show you something. This command right here, now, that program doesn't run under Windows Command Shell. We need to go into Bash, and then we're running a similar to Linux shell. Notice how it includes dash M Windows as one of the compiler flags there. And I don't actually want it to do that because that means it doesn't display, it doesn't have the terminal output. So here's how I'm going to correct that. I'm going to go, let's close that folder. Let's go here and let's use the same exact build script that I had for Chastris. Okay, let's see here. Oh, wait a minute. Oh, wait a minute. I just realized something. This is in the wrong location. I want it to be under the 0 SDL. See, I have a really old SDL example here, which is cool and all. And actually, this probably won't even work. No, that doesn't work. But here I'm going to go to 0 SDL, and if you look in Chastris, you'll see that. Wait, oh, that's Chastris, the original one with surfaces. This is the modern one. Now you see here, if I delete the executable here and I do this batch file, it will compile and run the Tetris game. So it will compile and run the Tetris game, and this is my Tetris game, Chastris. So yeah, that totally works. So, because this uses just the SDL library and no special extensions, I should be able to use the exact same script. And I'm going to show you the script exactly what it looks like. It looks like this. It sets the dev kit to be the directory where GCC is installed. And I've copied over the SDL files there and everything the way it needs to be. So it compiles with that command, but it does not include the Windows flag. And then it strips main.exe. Technically, not all of that is necessary. What I'm actually going to do, okay, I'm still going to, I know what I'll do. Well, first of all, I'm going to copy that script. Going to copy that into SDL chess. That's what we're going to do. We're going to copy that file here. Okay, there's my Streamlabs thing here. Okay. I'm going to open the terminal again here now that we're in the correct location. And let's see, dir, and we're going to do scoop sdl make.eap. Okay, now you're going to notice something. Now you notice how when I click on a square, it does work. It absolutely works. But now you have the text output on the left. So it said, if I click on the square, it says that it's location x2, y equals 3, and that it's a blank space. And its identifier is C5. So like here is E4, here's D4. So every square has a location in traditional chess coordinates as well as Cartesian coordinates. So that is helpful information there on the left. Not strictly required, but I use it for debugging purposes. So I want to make some changes because making a chess game is not something that is done quickly. And I've worked on this in only a few sessions so far, and we have a very basic rundown of what it's doing here. There's a lot of adjustments that need to be made. Okay, here, okay, wait a minute. I didn't really want it to, I don't want it to open the Visual Studio code. I actually want to, let's go to properties and let's change the default app that it opens in. We want to make it Notepad++. And there's reason for that, because Notepad++ is less annoying. It doesn't start saying, oh, there's errors, like, we can't find this file. Visual Studio Code is nice for some things, but for the most part, I use a simpler text editor. I use Notepad++ when I'm on Windows because it has syntax highlighting and is more than enough to display the relevant details here. So I'm opening main.c. Now the text is a little bit small here. Let's see, I don't know if people can see this or not. Okay, yes, Streamlabs is going. So I need to make the view bigger. I need to make the style configurator. Let's make the font size. Let's make it bigger. Let's see here. Okay, now that didn't make it bigger because we haven't made the yeah, let's make the font global. Yeah, because I know that there's different styles for each language. Let's see here. Enable, let's see here. Enable global font size. Okay. All right, that's what we want. We're going to enable the font size to be global. And we want, okay, here's what we actually want. We want a more, I don't know, we need a nice readable font. Let me try to see, okay, how about fixed system? Will that work? Well, it looks a little bit weird. The font is important because if I'm going to be looking at this and if people are going to see the source code, there needs to be a font that's readable. Let's see here. Wait, chess mark? What's chess? Oh, chess pieces. Okay, now that's really actually funny. There's actually a chess mark font. That's not going to help me read my source code. Okay, now what is the Yeah, this is tricky. How about terminal? How about, okay, system? Okay, let's go, yeah. Yeah, because I want to choose the right font. I want something that's readable. And I want to find something that's usable, like that's sort of a default font. See, Courier. Okay, let's see, Courier new. Okay, let's see. Okay, Courier is nice. Courier new is fine, but maybe we can make it bold. Can we? Oh, let's see. Wait a minute. Oh, I see. Oh, there we go. See, now if we enable, yeah, let's do everything global. Okay, yeah, now I've got it. Okay, let's see. Can we make the text up to 24 size? Yeah, let's do that. Let's make that bigger. So even though it's not perfect, actually, speaking of fonts, I'm curious, what font did I use in Chastris 1989? Oh, that's right. I used edit undo. That's not readable at all. Okay, so let's go back here. So now we're looking at the source code for the chase chess, and let's try running the program again. And you're going to see it does all of this, and there's a lot that it does. The pieces can't move yet. I'm first trying to get it to accurately detect where the pieces can move to if they actually did move. So that's the thing is I need to find a way to fix this. And we're going to go one piece at a time actually. For the king it's fine, and for the pawn it's fine for now. But we're going to fix some of these. Okay, so this program does several things. It includes several header files, 4 of which I wrote. 1 is only for drawing the checkerboard. And here, let's see here. I want to look, actually, let's see. I want to open and look at one of the other files. Here we have the file that controls the whole font. I have, all right. Yeah, the way I built my font library to work with a very specific font and the math only for that font is quite efficient. Very efficient. And it works, it absolutely works. Oh well, I understand it, but it's hard to explain. So here's the thing. Now, there are some optimizations that can already be made. Let's see here. We have SDL, okay, chase chess. Okay, now here's the thing. This file here, oh, it's opening in regular Notepad. Well, I can still understand this. It's not big though. Let me open, okay, wait. Oh, did I accidentally close Notepad++? Okay, here's what I'm gonna do. Let's open up from within here. Let's look at SDL Chase Chess. So I defined an array of board pieces and board pieces color to set the default values of, what was black, what was white, and the letters for each of those types of pieces. There's one for just printing. That was only for debugging. we have a structure for a chess piece, and each piece has a color. It's either a black or a white piece. Its ID is a single character representing which kind it is, such as Q for queen, K for king, and so on. So we have a global chess piece that will be used for analyzing all data about the recently clicked piece. And then this is another one, but it's a PS, global chess piece that will be used for analyzing data about the currently selected piece. Okay, and it's hard. It's a little bit hard to, you can't see all of the text. And all of this is subject to change if it doesn't serve the final program. And this is the function init main grid. So what you see here is right after the main function begins, it calls init main grid. And what it will do is, it can print that, but I have that disabled. Then it will go through every element of the array from y and x values from 0 to 8, and it will set up the grid array at that specific index, x plus y times the width, which the width is always 8, equals chessboard pieces of that same index. And in fact, I can see an optimization that could be made here, but I don't really think it's necessary. I would just want it to work. So, and for example, let's show how the chess grid print function works. If we uncomment that and then do this, then we're going to see as soon as it runs, not only does it display here, but it also displayed as text characters. That was one of the earliest functions I wrote just to make sure the array looked the way it was supposed to work. Also, out of curiosity, what is my my terminal? How do I? Yeah, I don't know how to control the terminal font. I really don't. So as you see, that's what it does. But anyway, let's put it back the way it was. So it prints the grid, or not. It creates a video mode. It creates a window. It initializes SDO, creates a window, does all this stuff, initializes the checkerboard, sets the rect size, what it should be, which is height divided by 8, and then it does an initial image. The initial image, it does chased font load, it loads the font, all of these things, and then it finally draws and presents. So before it begins the loop, it draws. So that's where we're at. So when we compile and run it, it's at that point. It's drawn the default image, but then the image changes every time we click on a square. So that's where it's at. And then it does some really fancy stuff here. It goes to this loop. Loop equals 1. A while loop is equal to 1, or at least it's non-zero. It always goes with this game loop. So at the beginning, it pulls the input, it sees if there's any input, and if there's mouse input or keyboard input, it will process it. So if I press escape, it ends. If I click the X, it will also end. If I click the mouse button somewhere, if it's a mouse button down, it gets the button values using the X and Y variables. And it can display information as text, but then what it does is it divides that value by the rectangle size to get the actual value of what it will be. So it can tell you a number from 0 to 7 of both X or Y. And then what it does is it sets the piece, which is P, to equal the main grid array element at that index, the formula X plus Y times 8. 8 being the width of the chessboard. That never changes, so it's hard-coded. So that's what it does. All it's doing there is printing the information on which chess piece, which square is being clicked, and it prints information based on the value of the PID. So if the PID equals 0, it's a blank space, and that's all it prints. Else, if the p.color is black, it'll print black. If it's W, white. And then it tells the name based on just the letters. So P is pawn, R is rook, N is knight, B is bishop, Q is queen, and K is king. So that's only displaying in text what piece it is. That's all it does. So then it draws the checkerboard. After displaying the text information, it draws the checkerboard it sets the render color to that, then fills a rectangle of the entire screen there with that shade of gray. Then it renders a checkerboard with the squares of a different gray. And see, I can change all this. If I change this to 0, 0 instead of 5, 5 hex, then it's going to look different. Well, it doesn't show it right now, but as soon as I click, see how it changed? Because the code that draws it out in the game loop is separate from the code that draws it at the beginning. So it looks very funny. So I changed to purple. I have complete control over the colors of the checkerboard and every other detail. So yeah, now it's back to the way it was. So it draws the checkerboard, and then this is the highlighting step. Here's what it actually does. Now P, you have to understand, P, the chess piece P and the piece selected, which has not been used yet, that's a global. That's a global variable, and it's included before the main function begins. Right here in SDL chase chess, right here, it's included. So here's the thing, the highlighting code right here, this is part of what makes it difficult. Because see, I have the highlight, actually the highlight code is not in this file. It's actually, it's actually in the graphics file. Let's see here. Let's go to the graphics. So here, there's the chess grid draw, which draws the text characters of which chess pieces are where, keeping track of what's a black or white piece to draw. Okay, now here's the chess grid highlight function. This is a very small function here. First it checks for out of bounds, and then it checks, it gets that element there. If it equals 0, it'll basically be, it will just, so if something's highlighted, it sets the render to green. Oh yeah, that's right. So if it's empty, it's green. Else, it ends up being, it ends up turning it red. So this just displays it based off of that. It's simply giving it an X and Y value based on what's at that spot. It will, it will do something different there. So there are some adjustments that should be made to it. For one thing, this game needs to differentiate between which pieces can be captured and which can't. Okay, so here's what we're going to do. So at this point, so the PID here, the piece that was just clicked here, Okay, let's see here. We need to differentiate this. We need to correct this. So okay, I think I know what to do here. It's hard to explain, but I think I know what to do. Let's see here. Checking on the stream here. So what I'm going to do here is, well, I do need to adjust some of this code here. First of all, now this, see, this is a long stretch of code. This is a very, very long stretch of code. So you see that it draws the checkerboard, but then all of this stuff here, this is all stuff, well, it's kind of complicated to explain this. Well, we can fix that later. But yeah, it does different things for each type of piece. But it's so long because it checks every individual piece. And then it draws the grid. But we really need to fix something here. So here we have, because there's the chess grid highlight, but we need another function after it. And what will I call this function? Let's see here. We're gonna call, it's gonna be a void function, of course. Void, okay, we're gonna check moves of clicked piece. Oh yeah, I could have just done check moves, but check moves of clicked piece seems much more descriptive. That's what we're gonna do. So what we're gonna do here, we're gonna move that there. In fact, we'll close that one for now. So all of the code that goes in this big old main function. So from here all the way up to here. So that's, yeah, if it's, so there's the queen, there's the king, there is bishop. See all of these different things, all of these, see all of that is what it's already established at this point which piece was clicked. So yeah, it does. All right. So here, after it prints the information in text form. Okay, now that we know which square was clicked and what piece is there, the major step is to highlight which squares it is possible to move it to. So here's what we're going to do. We're going to copy all that text. Actually, we're going to cut all the text and we're going to place it inside here. That's what we're going to do. I'm going to save this file. I'm going to save this file. Let's see. What does it do? So the program still compiles and runs, and that's totally good. But it now, notice it no longer is highlighting the different moves that should happen. That's because the code was deleted from the main.c source file. And the reason it was deleted from there is because it made the main function just too big, too unmanageable. So now here's what we're actually going to do. Also, I want to test something. What happens if I can even put that down there, and theoretically, it should still run with that error. Yeah, that's not necessary to do that. But what we're going to do is we're going to check the moves of the clicked piece. Okay. So now, let's try this. Oh, orange state with no effect because it's a statement, but we forgot to put the parentheses for the function call. Almost as bad as forgetting a semicolon. Now that we've put it back in there, you see that it's back. So I do want to fix some things about this, clearly, because notice that when the rook tries to move, or its tiling moves, it correctly detects that it could theoretically move onto a blank space. Green means it should go, red means it will not go. But notice it does that for that, but then it has red for both the white and black pieces. And technically that is, excuse me, I had to sneeze. That is actually not what I wanted to do, because a white rook should be able to capture a black rook or pawn, and the bishop, or the queen, should be able to capture the black queen or pawn. So I need to have it directly. I need to be able to have it detect correctly which pieces it can capture and which are red that it can't. So we need to fix this. I need to fix this program. So I'm going to change some things around here. So what we're going to do here, this function here, because see, the chess grid highlight function is called by the check moves of clicked piece function repeatedly. Over and over it calls this. So here's what we're going to do. If the main grid array equals 0, if it's a blank space, then yeah, it'll be green. However, okay, so we're gonna do it if else if, okay, else if, okay, so okay, if main dot grid array of that index equals p dot color. Okay, so if the if that index, that color of that piece at that index equals the same as p dot color, which is the current piece color, then it's going to then it's going to make it red. Okay, let's try this. Let's try moving that one to there. Okay, so if it equals, so if it's the same color as the currently clicked piece, it will change it to red. So let's try. If I do that, Okay, let's try. So now, ooh, you see, now it differentiates. So now the rook, it can't capture the other white pieces, but it can capture black pieces, and the same with the queen. So now we fixed the detection of the way it works. That's what we've done. We fixed that detection of differentiating between the pieces. Okay, that's cool. But there's something else we need to do. These pieces cannot jump over the other white pieces. So they can't actually move onto the squares beyond the pawns, except for the knight. The knight, of course, is special that way. So how do we fix this? Oh, and let me also check the black pieces. Yeah, same thing. It's fixed correctly for the black pieces can capture the white pieces. Okay, that's nice. And also, there is something that's going to be important to realize here. When we highlight the pieces, we're giving a visual display, but we're not changing any data. We need to fix that. So here's what we're going to do, is that we're going to create a new highlight array. Okay, so let's try something. Let's open the chess, SDL Chase chess folder. So notice how there was a char array of the board pieces, 64 characters there, and there was that. But what if we had something else? What if we had, let's see here. Well, we don't need to have everything initialized in that way, but we're going to have, okay, there's going to be chessboard pieces highlight. Well, that's what we're going to do. We're going to just keep it similar because we're going to be highlighting. Okay, so we're going to make this array here. It's going to be a global array. It's going to be exactly 64 elements, 64 squares on a chessboard. And notice how just as this now, okay, that was chessboard. So where is the init? Okay, so there is a init main grid. So here's what we're actually going to do. But because it's just a basic array, it's a very chessboard pieces. Okay, here's what we're actually going to do. I'm thinking this over, how I'm going to go about this. We're going to, okay, we're going to, let me see how this looks compared to that. Okay, we're going to go to the graphics, and here we're going to have an init, okay, init, okay, okay, we're going to have chessboard, okay, init board, okay, board highlight. Okay, we're going to initialize the board highlight. And, okay, chess, okay, okay, chessboard pieces highlight. Actually, okay, let's, instead of having a really long name, let's just have it be highlight. Just highlight, okay, init, or we're just gonna have init highlight. Gonna call it highlight, but it's actually gonna function as more than just highlight. Okay. So, but what we're gonna do is, instead of main.grid.array, we're gonna be just doing a plain, not a structure, just a plain highlight. That index is going to be set to, yes, okay, we're gonna set that character will be equal to G for green. Okay, G for green or go. That's what we'll do. That's one way of doing it. I've thought about doing it more than one way, but we'll do G for green. Oh wait, no, wait. Oh wait, no, we don't. Oh, okay, I'm thinking about this wrong. Okay. Okay, let's set this for, okay, here's what we're gonna do. We're just gonna have it be a plain 0 or 1 value. Yeah. Okay, it's gonna be 0. It's gonna set just the highlight to 0, meaning that it's not highlighted. So if it's 0, it's not highlighted at all. So init highlight. So what we're gonna do here is we're going to initialize a highlight, and what we're going to do is every time that right before we do the check moves with clicked piece, we're going to initialize the highlight. We're going to have to do this. We have to 0 all of the elements of the highlight array. And we're not actually using the highlight array, we're just setting up the code. Okay. Okay, so let's see here. So it should still behave the same way. Basically, it should still, wait, what's wrong? What? Wait, something is wrong. Something is very, very wrong. Okay, I think I know what happened. I think I know exactly what happened. Okay, so here, see the global, okay, so the X and Y values using this are local. And here, okay, I see how it is. I see exactly. And then those use the global, but because the X and Y values for the highlight function, because those are the global X and Y, it doesn't work. So int X, Y, local variables, so they don't conflict with the global variables. That's the way to fix that. Let me see if it works now. Okay. Okay, now the pieces are behaving normally. And whether I right click, left click, or middle click, the result is still the same. So everything is operating as it should. Now notice that, see, the rook moves in vertical or horizontal, bishop moves diagonal, but queen moves both. Well, here's what has actually happened. Okay, we're going to go here. The rook moves, here's what it does, is it does each of the 4 directions, starting at that current piece. So x1 equals x plus 1, it does a thing for each of the 4 directions. It tries from each one of those locations to the side. And it does that, it does a loop. So for example, while x1 is greater than or equal to 0, it will subtract 1 from the x position, and then it will try to call the highlight function for each one. So that's the rook ones. And then the bishop ones, I mean, it absolutely works. And notice how I copied, okay, first the rook move of the queen, then the bishop moves of the queen. But notice I had to copy and paste all of that code, and it's very long. We can shorten the code. In fact, let's do something. So I am going to, okay, let's see here. So let's take a look at the size of the source file. So notice how STL chess graphics here, the size of this file is 4,639 bytes. Okay. And here's what we're going to actually do. I'm going to go to GitHub and I'm going to back up the files. Okay. I'm going to go to my GitHub account and back up the source files here. Okay, for some reason it always goes to that page. Okay, I'm going to go to Chase Chess because I have updated some of the source files here. So it's important to always online backup these. And I always back them up to my Patreon after I've made significant progress here. So let's see here. STL Chase Chess. Okay, so here we are. Which files have been modified? Okay, so today that's the oldest file. Okay, so right. So the files that have been modified are of course the executable, but then STL Chase Chess graphics. Interesting. Notice that STL Chase Chess has not actually been modified. I reviewed it, but I haven't modified it anyway since the 19th. So technically, only these two files, main.c and STL Chase Chess Graphics, those files have been updated today, February 2nd, at 6:22 a.m. So I'm going to upload them to the source. That way I have a backup in case I screw anything up. It's always important to back things up. Notice how it says an experimental project that may turn into a chess game. I don't know if it's going to turn into a chess game or not. I really don't. But I'm going to do something. So what we're actually going to do now, wait. Okay. I need to, I don't, see, I have to reconfigure everything on Windows. Windows is a pain in the ass. I don't even have to do this on Linux. Like it just opens with mousepad on my Debian Linux. Okay. Let's see here. We want to change the default app to be Notepad++. Apply. Now if I double click it, so it's going to, we're going to chess grid highlight. Okay. It highlights that square by setting up the rectangle and filling that rectangle with that color. Okay. So, okay, I'm going to make it not very big. Actually, let's not do a comment right now. I can always write the comment later. Okay. So here we have, so here's the rook moves. Actually, yeah, let me see here. If PID equals R. Okay, so here we are. We're going to select and cut everything there and put a placeholder. Okay. Okay. Let's see here. Okay, so void check moves rook. All right, we're just going to make a separate function where we paste in that code. So everything there is going to be where, okay. And I think Notepad++ is trying to auto-indent things too, which is annoying. So we have that one. So check the moves of rook. And we're going to put this one here in that placeholder. Okay. Next, we're going to do this and select everything in the bishop section. So now, placeholder there. Okay. Then we're going to do the same thing. Check moves bishop. Okay, yeah, because see, there's that. Yeah, that's correct. Syntax highlighting is nice, just to make sure I've selected the right braces. Okay. Okay. Void check moves bishop. All right. All right. Paste that in there. So now the bishop moves. Yep. Yeah, getting those looped just right was tricky, and I want them to only be in one place, so they only need to be fixed once. So now that we have a separate function for checking the moves of the bishop, we're going to, okay, so here we have this. So let's see, first of all, does the program work successfully? Okay, we need to put the braces back here for function call. So now let's compile and run the program. Does it work? Okay, it still works. It still works correctly. That's fine. That's totally fine. Okay, yeah. So now we know it works. So now that we already have functions for checking the moves of the rook and the bishop, let's delete some extra lines there. What we're going to do now is we're going to go to the queen section. We're going to simply delete all of that code. And then check the moves of the rook. Let's have only the moves of the rook checked. So the queen only checks the rook moves this time. All right, so now let's also have it check the moves of the bishop. All right, so now if when the piece is a queen, it's going to check the moves of the rook and the bishop. Let's try this. Hey, it works as it did before. So it works. So now here, wait, something's wrong. Wait a minute. Something's not right. Wait, what happened? Oh wait, no. Wait, no, that's right. That's right. That's right. Yeah, that's all correct. Yeah, okay. Everything's correct there. At first I thought there was something wrong, but no, actually. I just clicked on the knight. Wait. No, that's right, because the bishop moved diagonal that way. Okay, so nothing is actually wrong here. The code worked exactly as it did before. It totally works. So now the queen simply checks the moves of the rook and the bishop, because everyone knows that's exactly what the queen does. It moves the exact same way as a rook and a bishop combined. So I have not made all the improvements I want to make to it, but let's take a look now. Let's directory. So now the size of the chess graphics file. Hey, it was 4,600 something bytes. Now it's less than 3,800. I have removed almost 1,000 bytes from the source file by having functions that can be called twice instead of copy pasting all the code. So it works, but that's actually pretty good. That's actually very good. And I know now that the program still works. However, there is still the small matter of the fact that the stream has actually gone on for a while. Nobody's watching. I'm going to end the stream for now, but I have made a small amount of progress on my chess game here. So I will